This conference will now be recorded.
Hi everyone, welcome to our Oracle Goldengate Classic Architecture Training Day 1. My name is Ashish and I'll be delivering this lecture to you. So before commencing the session, just a quick round of I just wanted to update you about my YouTube channel, which is dedicated to Goldengate. So I have my own YouTube channel, which is youtube.com/Ashish Agarwal _GG. The channel is dedicated only to Golden Gate. You will find a lot of Golden Gate related videos which can be helpful. So do like and subscribe the channel, and if you have any issues, questions, do let me know. So do like and subscribe. So let us start as day one. So so today is our first session of Oracle Golden Gate Classic Architecture training. Now the question which is being asked a lot from me is, what is classic architecture? So we'll be discussing about different types of architecture today, and then different types of extracts, different type of replicats. So we'll be discussing all that today, and then we'll be discussing about architecture, classic architecture, how process data flow. So we'll be discussing all that in today's session. So agenda of this training include a lot what is mentioned over here. So introduction to Oracle Golden Gate, types of architecture, Oracle Golden Gate architecture, installation of Golden Gate, download of Oracle Golden Gate, concepts and components related to Golden Gate, DML replication in Oracle Golden Gate, how process data flow, parameter files in Oracle Golden Gate, initial load, data filtration and transformation, bidirectional replication. So in this session, we are going to discuss a lot about bidirectional loop detection, bidirectional auto CDR, what is active bidirectional, what is active passive bidirectional. I will be introducing a lot about that. Then DDL replication, how to perform DDL replication, how you can replicate roles, users as well in Oracle Golden Gate. Then how to monitor the lag. So in this session, we are going to discuss extensively about Oracle Golden Gate performance, as well as we'll be discussing about new features like performance matrix server, Golden Gate heartbeat table, which I have introduced recently into my session. So next, during this training program, we'll also be discussing about troubleshooting. So troubleshooting you will find in most of the sessions. Troubleshooting, what I try to do during the session is, basically there are so many issues in Golden Gate. So today if you're facing some issue, it may be possible tomorrow you're facing the different issues. So what I always say, if your approach towards the issue is proper, if you're approaching the issue proper, trust me, related to any issue in any technology in today's world, you can resolve that issue. So the main purpose of the training focus is, you will be I will try to involve you how I will try to make you understand how to troubleshoot, how to approach the issue. So once the approach is good, you can troubleshoot any issue. Then next we'll be discussing about Golden Gate checkpoint, which again is related to performance. Then we'll be discussing about Golden Gate security, parameters, log dump. Along with that, we are also going to discuss about Golden Gate 19C features, Golden Gate hub and spoke architecture, and Golden Gate include files, obey files. We'll be discussing a lot. So basically, we are going to cover a lot of things during this training sessions. So next 18 to 22 hours, you will be learning a lot in Golden Gate. And one thing before I will always say that training session is completely practical. I urge everyone, whatever we are doing, try to implement that practically. See, you will be able to understand the session, that's what I assure. But once you implement the things practically, that where you learn. So do as much practical as you can. Try to create different scenarios. I'll be providing you different scenarios during training which you'll be implementing. And if you're stuck anywhere, don't hesitate to ask me. Also, make use of the WhatsApp group. That WhatsApp group, many people know, they have achieved a lot of good things from the group. So do proceed with the learning. So let us start our training program. Okay, so the training what we are doing today is related to Oracle Golden Gate classic architecture. So before I proceed to Oracle database architecture, let me proceed with types of Golden Gate architecture. Okay, so so there are two types of Oracle Golden Gate architecture available in current scenario. One is Oracle Goldengate Classic Architecture and second is Oracle Goldengate Microservices Architecture. Now what happened? Oracle, so basically Goldengate was the product which was developed separately, independently I should say, in 1995, and it was basically developed for ATM networks and it was named after famous San Francisco Golden Gate Bridge. So Golden Gate, Oracle Golden, basically Golden Gate is a product which got its name from the Golden Gate Bridge, which is located in San Francisco. Now, until 2009, that was a standalone product. Golden Gate was an independent company, and it was mainly used for ATM networks. Now, what happened in 2009? Oracle overtook it, and since then, it is known as Oracle Golden Gate. Now, until from 2009 until 2017, there was only one way to configure Golden Gate, and that was through command prompt. So if any of you or many of you may have worked on Golden Gate, they must have seen Golden Gate related environment in their work or in their in their own machines or in their own environment. So you must have worked on GGSCI. GGSCI stands for Golden Gate Software Command Interface. So it's a command line interface. It's a command prompt based architecture which allows you to set up, configure, manage Golden Gate through command prompt. So until 2017, there was only one way to configure Golden Gate, that is through GGSCI. And until 2017, we used to call it Oracle Golden Gate. Now, what happened? In 2017, Oracle renamed Oracle Golden Gate to Oracle Golden Gate Classic Architecture. So basically, the existing architecture of Golden Gate, that is GGSCI or command prompt one, was renamed to Classic Architecture, and now in 2017 they launched a new architecture of Golden Gate which is known as microservices architecture. So it is RESTful API based architecture, and it has been launched keeping in mind future of Golden Gate, which allows integration with cloud application and allows you to set up, manage, configure, troubleshoot Golden Gate through GUI. So now we have two types of architecture available in Golden Gate: Oracle Golden Gate Classic Architecture and Oracle Golden Gate Microservices Architecture. So if I have to sum up in few words for you, Oracle Golden Gate Classic Architecture is the traditional architecture which is existing since the Golden Gate has been developed. Microservices is a new architecture which has been developed to allow Golden Gate for cloud integration as well as to introduce or to allow GUI based configuration setup or troubleshooting. So now we have two types of architecture: classic and microservices. Now remember, classic architecture is available for Oracle as well as non-Oracle databases. So if you have Oracle or non-Oracle, you can use classic. However, microservices architecture is, as of today, when we talk about, it is only available for Oracle databases. So if you want to set up Golden Gate for say for example SQL Server, you definitely cannot use microservices as of today. You can only use classic architecture as we talk today. Definitely in future, Oracle, last time when I had a word with Oracle, they have definitely planned to launch microservices for uh, different databases as well. Okay, so classic architecture and microservices architecture, these are the two types of architecture available. So during this training program, we are going to talk about Oracle Golden Gate Classic Architecture. So next 18 to 20 hours on weekdays, you will see we are talking about this classic architecture. Okay, now another product of Oracle Golden Gate family is Oracle Golden Gate Veridata. So you might have heard about Oracle Golden Gate Veridata. So it's not type of architecture. I'm just letting you know about another product of Golden Gate family, which is Oracle Golden Gate Veridata. So Veridata, as the name suggests, it verifies the data. So if I have to extend the name of Veridata, I call it verifying the data. So what Golden Gate does basically, it replicates the data from source to target. So if in source you have, say for example, 10,000 records, on target you have 9,999 records. So So how can you find? Either you can run SQL script for that, or you can write some PLSQL code, or other option is you can use Oracle Goldengate Veridata. Now, Veridata is a separate license product. I'm not going to talk about licenses because I'm not license specialist. I can only talk about technical. But yeah, Veridata is a separate license product. Now, you may say, Ashish, why do I need to use Veridata? Why can't I use SQL script? So consider a scenario wherein you have 100,000 records or 10 million rows. In that scenario, if you run SQL script, what will happen? it will it may not give you the exact result, because otherwise you might need to take downtime, and another thing is it will take a lot of time. Veridata is a product which can check the data discrepancy for you in real time, considering or taking into account what are the in-flight rows, and it doesn't need any downtime as well. It doesn't need any downtime as well. Okay, so Veridata is a product which is another product of Oracle Goldengate family. So Veridata is very widely used right now. I would say in the places where cloud migrations are going on. Organizations want to see whether uh, they have once upon migration of the database, they want to see whether the data is in sync or not, so they can use Veridata. So Veridata is another product of Oracle Goldengate family. And another thing is
Ashish,
certification wise of Veridata as well. If you go for Goldengate certification as well, Veridata contains around 10 to 15% of questions. Okay, so related to architecture, any questions? So during this session, we are going to talk about classic architecture. Okay.
Ashish.
Yeah, Manoj.
So the validator, you said it's for comparing the data between the source and target, right?
Exactly, yes.
So in what situation we compare the data? Is it just for the reporting and checking whether the source and target are in sync, or we just find out the missing records and then replicate in the target?
So Veridata has the capability to repair it for you. So consider a scenario: you have data running for 2 years, and after 2 years you are identifying the discrepancy. So you can run. So it depends on organization. It depends on how do you want to take data discrepancies into consideration. It depends on that as well.
Okay.
Okay. So it depends everything. Okay.
Yeah, that's good.
Okay. Okay.
What do you mean by repair? I mean,
Repair means if one row is identified as discrepant, Veridata can repair that for you. So basically, it can get databases into sync. Okay.
sure.
Okay. So during this training, as I mentioned, we are going to talk about classic architecture. That was just for your reference. Now, another question which I'll take later, or which you might be having, is related to classic and integrated. So many people they ask this question still, that if so when I talk to them, or in fact over email, or over my LinkedIn messaging, or over my YouTube channel, I receive a lot of comments related to, does classic architecture no longer, sorry, it does integrated uh, integrated architecture no longer exists? Does anyone else has that question? So I mentioned classic architecture and microservices architecture. Nowhere I mentioned about integrated one, right? So does integrated one does not exist? Anyone has that question? Definitely many of you would have that. So remember, so this is where the terminology difference is there. So what happens is, here we are talking about type of architectures, classic and microservices. So in Goldengate we have different type of extracts and replicates available, like integrated extract, classic extract, then replicate. So what we are talking about here is, these are the types of architectures. Now here what we are talking about is types of extracts and types of replicates. So basically these types of extract, integrated extract, classic extract, reside inside classic architecture. Integrated replicate, classic replicate, coordinated replicate, parallel replicate reside inside classic replicate. Similarly, these two, integrated extract and classic replicate, resides as well in microservices as well. So basically the purpose of saying is these we are talking about types of architecture. However, what we are talking about here is type of extracts and type of replicate. So integrated extract still exists, classic extract still exists, integrated replicate still exists, non-integrated replicate still exists, but those are the type of extracts and replicate, and those type of extract resides inside classic architecture as well as those resides inside microservices architecture. Now these type of extracts, replicates, this is only for those who had that question. Now what is the difference, what are the types of extract and replicates, I am going to cover that later on during the part of the session. Okay. So let us now move to our training. So those are the type of extracts, those are the type of architectures which we discuss about, which will help you in learning. So we are going to start with Oracle database architecture. So in Oracle database architecture, basically we are going to discuss about what is needed for Goldengate. So Oracle Goldengate is a change data capture tool. By change data capture tool, we mean that whatever changes are happening in the database, all those changes will be captured by the Goldengate, and then same will be applied onto the target database. So in case of Oracle, the changes are written where? The changes are returned to redo log files or backup of redo log files, which are known as archive logs. So whatever changes are being made to the database, say for example you are doing any DML or you are doing any DDL, those changes gets returned to the transaction log. So in case of SQL Server, MySQL, we call those changes, where the changes are stored, we call them as transaction logs. However, in case of Oracle, we call them as redo logs or backup of redo logs, which are known as archive logs. So Goldengate is a change data capture tool which captures the changes from source database, and then those changes are applied onto the target database. So whatever changes are happening on the database, all changes will be returned into the redo logs, and same will be applied. So basically those will be captured, and who is the source for them? It's the Goldengate, it's the database transaction logs. So what happens about Oracle database architecture? So Oracle database architecture is divided into two parts: instance and Oracle database files. So instance again is divided into two parts: uh, memory components and background processes. So memory components are library, so SGA, so basically library cache, data dictionary cache, data buffer, database buffer cache, Java pool, redo log buffer, and large pool. All these together forms the memory part of the instance. And background processes include pmon, smon, database writer, log writer, checkpoint, and others. So these are the background processes which makes your which allows you to write the data to the data files or store the data in the control files. Then Oracle database files, actual database files are your data files where the changes are, where the data gets written. So say for example you're querying select star from DPT. From where do you get that information from? From the data stored in the data file. Control files stores the metadata information. So basically control files are the heartbeat of Oracle Goldengate. If control files are missed, those are the critical files, then it becomes an issue. So control files stores the metadata information. And then you have redo log files. So redo log files refers to the changes, whatever changes are being made to the database, those changes are recorded into the redo logs. And because redo log size are limited, so once the redo log files get full, the backup of redo log files is taken on disk, and those are known as archive log files. So basically what happens is whatever changes are made, the changes, say for example you do any insert, update, delete, or you do any DDL change, what happen, those changes gets returned to database buffer cache. So before database buffer cache can write the data from, before database writer can write the data from database buffer cache to data file, log writer process writes the data from redo log buffer to redo log files. So say for example you updated the record. So what happens? The dirty buffer will be returned over here. Now from dirty, once the buffer becomes dirty, a copy of that gets returned to redo log buffer as well. Now database writer process writes the data actually to the data file, but before database writer can write the data from database buffer cache to data file, log writer process is responsible for writing the data from redo log buffer to redo log file. Now under what conditions log writer process writes the data from redo log buffer to redo log file? At commit, or it is 1/3 full, or when there is 1 MB of redo every 3 seconds, or before database writer process writes. So basically all the changes whatever are happening, whether those are DML, DDL, committed, uncommitted, those changes gets recorded into redo logs, and backup of those when redo logs are taken, then it is called as archive logs. So when does redo log buffer actually comes into picture? Say for example your database crashes in between before database writer can write the data from database buffer cache to data file. So what happens before, as soon as you get your database backed up, means your database is up, you apply the you apply the data from redo log file, you basically redo the data from redo log file to data file. Whatever changes were left to be applied to data file when the database was crashed. So same redo log file are being used by any change data capture tool, like when we talk about data guard, when we talk about any change data capture tool like SharePlex. So Goldengate falls in the same family. Goldengate is a change data capture tool which captures the changes, whatever changes are happening in source database. So we call them as transaction logs in case of other database. However, in case of Oracle, these transaction logs are called as redo logs or backup of redo logs, which are known as archive logs. So Goldengate source files are always redo log files or archive log files. Remember, these files contains committed as well as uncommitted data. Okay. So there are lot of data replication tools available in the market. I should say competitor of Oracle Goldengate, like you have EMC Recover Point, IBM Mirror, Hitachi True Copy is there, HP Continuous Access is there. Then you have Symantec Veritas, Data Course and Symphony. Then you have also have uh, SharePlex as well. That is one of the major competitor of Goldengate. And some people always say, can DataGuard be competitor of Goldengate? No, DataGuard is not competitor of Goldengate. Okay. So, okay, Rajesh is saying there is one HVR tool. I haven't heard about that. Oracle Streams, Vamsi is suggesting Oracle Streams, but remember, Oracle Streams is obsolete now from 2 onwards, and 11G is no longer, sorry, Streams is no longer the no, Streams is obsolete now, it is deprecated, and in fact Goldengate replaced Stream now, so it is not a competitor now. Okay, so there are competitors of Goldengate present, but still why Goldengate is popular, the reason being data is sent in real time with sub-second latency. So one thing what we always confuse ourselves is Goldengate is called as real-time replication. Remember, Goldengate is not a real time. It is near real time. So definitely, I find it really very funny. Some people ask me, our environment is facing the lag of 2 seconds or 8 seconds. Can we get it down? So I always tell them one thing if they are asking me this question. So one thing is, better than this is less than 0 seconds. That means that if that means that Goldengate should be able to know that transaction is there even before commit happens. So Goldengate should be able to capture the data before even the commit happens on source. That can be the only solution, but that is not possible, right? So Goldengate is near real-time solution for replicating the data from source to target. So with Goldengate, data is sent in real time with sub-second latency. So there, so 2 seconds, 4 seconds, 8 seconds, Goldengate can replicate depending on your configuration, your design, your network bandwidth. Goldengate supports heterogeneous environments across different databases, across different database and hardware types. So Goldengate can support your uh, Oracle database, non-Oracle database like MySQL, SQL Server, Informix, Postgres, NoSQL. And another advantage is your source need not to be, your source can be on Windows, target can be on Linux. Source can be Sun Solaris, target can be HPUX. Goldengate can replicate the data. Now, high performance with low impact. So see, one thing is Goldengate is a tool which is external to the database. So definitely, uh, it is a tool. Because it is a tool which is external to database, it may have some impact on the database. See, it's an external tool. However, the performance it delivers is very good in comparison to impact it has on the database. So Goldengate delivers high performance with minimal impact. Goldengate can move large volume of data very efficiently. So you can move your, so prior to 12.12c, there were some issues with lob, blob, glob. Now Goldengate it has basically extended its capability to a lot more data types. And another thing is prior to 12.2, in fact, with classic extract, now with integrated extract, there are no issues, but with classic extract, you had to do for ASM configuration or rack configuration, you used to do some extra setup, but with integrated, you don't have to do anything extra. It's like normal. So Goldengate is now very seamless, very easy to configure, very easy to set up, and it can move large volume of data very easily and efficiently. Definitely to achieve near real-time latency, your design needs to be proper, your setup needs to be proper, and your network has to be good. Okay. No single point of failure. So by no single point of failure, we mean that Goldengate troubleshooting is easy, and also basically each step basically there are different steps involved. So if the Goldengate setup is proper, you're not going to face issues with Oracle Goldengate. Now with Goldengate, it supports heterogeneous environment. So your source can be Oracle, target could be Oracle. Your source could be Oracle, target could be non-Oracle. Your source could be non-Oracle supported database, target could be non-Oracle, or yeah. So and source could be non-Oracle, target could be Oracle.
So Ashish, one question here.
Yeah. May I know your name?
I'm Srinivas. Oh, so when you are comparing with DataGuard and Oracle Goldengate, so if I'm talking about the Oracle to Oracle replication, so how will you differentiate this product?
So there are a lot of differences, I'll tell you. Like I'll name a few and then we can talk about that.
Yeah, sure.
As well. So basically I always say one thing. You can compare apple with apple, but you cannot compare apple with orange. Same thing, same analogy I give when I compare DataGuard and Oracle. So basically Oracle has its capability. One of the capability include heterogeneous and homogeneous. So Goldengate supports heterogeneous databases as well as heterogeneous platforms. DataGuard doesn't support that. Okay. DataGuard only support homogeneous database and homogeneous platform. So if your source is Linux, target has to be Linux in case of DataGuard. Source is HPUX, target has to be HPUX okay. In case of DataGuard. However, with Oracle, Goldengate, that's not the case. Source can be Windows, target can be Sun Solaris. Now, another thing is heterogeneous database support. Goldengate supports your SQL Server, or Oracle or any other database, heterogeneous databases, Goldengate supports only.
That I got the point. But
Now,
mainly I was talking about the Oracle to Oracle. So apart from the different versions can be supported by Goldengate, but whereas DataGuard, it has to be on same version. Other than that, the replication process is same, right? Am I correct?
now, so another thing is with Goldengate and DataGuard, I always say one thing. DataGuard is database level replication tool.
Right.
Golden
Okay.
Gate is object level
Object
replication.
level replication.
DataGuard can only be used for replication. Golden Gate
Right.
can be used for multiple purposes, like you can filter out the data, you can transform the data, you can use Golden Gate for business intelligence, you can use Target for reporting. In fact, with Active Data Guard as well, that reporting purpose is also supported with Active Data Guard as well. So that used to be the difference earlier, now that's not a difference. But yes, there are lot of differences. So again, Golden Gate is an object level replication, Data Guard is a database level replication. Like alter system commands, you can replicate through Data Guard, but with Golden Gate, you cannot replicate alter system commands. Sys system cannot be replicated either.
Hi
Okay?
Ashish, this is Kinjal. Can you please tell me what is replication of data, like object level, and what you said for Golden Gate?
So we'll be discussing that. That part you'll be learning as we'll be moving forward.
Okay, okay.
Okay?
Okay.
Okay. So again, another thing Tanny has mentioned is you can use Golden Gate for upgradation, you can use Golden Gate for migration as well. Yeah, so that's true. Okay.
One.
So
Hey Ashish, you told like heterogeneous data guard is not possible. That's not exactly true, but certain platform it's possible. Like you can have data guard.
see that what you are saying is correct, but again, that does not hold true in exact scenario. So I'm not going to talk about that, but as of now, yes, that statement holds true. Data guard does not support heterogeneous databases. Okay. Okay. So now, why Golden Gate? So now another thing is, apart from technical reason, why Golden Gate? So Golden Gate complements existing Oracle products, like it supports heterogeneous systems, real-time data access for reporting. Golden Gate, along with ODI, is one of the best business intelligence tool available in the market for business intelligence. It supports zero downtime migration and upgradation. So you can use Golden Gate for zero downtime migration and upgradation. Now, Golden Gate is widely used. You name a service today, what you are using. Uber, Golden Gate is being used. Facebook, Golden Gate is being used. Netflix, Golden Gate is being used. So whatever service you are using today, financial institution, talk about any bank, Bank of America, State Bank of India, Royal Bank of Scotland, any big bank of the world is using this Golden Gate. Talk about, so ATM networks, Golden Gate was initially, as I mentioned, in 1995, it was developed for ATM networks. So Golden Gate is being used in all ATM networks. Then telecommunication provider, name a telecommunication provider, AT&T, Bell, Sprint, Vodafone, Airtel, Etisalat. Name a big telecom company in this world, Rogers. Everywhere Golden Gate is being used. So Golden Gate is very widely used because of its capabilities, because of its solution it provides. So solution it provides are high availability. So it ensures that database is highly available. So say for example, your source is in Boston, target is in New York. Boston has some issues, electricity failure. So you can quickly switch over your application to New York, making your databases highly available. Zero downtime upgradation and migration. So Golden Gate supports zero downtime upgradation and migration. So say for example, you have to upgrade your database from 11G to 19C, 12C to 19C, 18C to 19C. So if you have to take downtime, consider a database size of 1 TB, 10 TB or 20 TB. How much downtime you need to take? Minimum 8 hours. Do you understand how much revenue your organization may have to avail in that scenario? So Golden Gate can support zero downtime database upgrades and migration, which we'll be discussing during later part of the session about strategizing it. Live reporting. So you can use your target server for target database for live reporting. In fact, one of the initially when I started, one of my project was for State Bank of India. Now, State Bank of India, it's definitely, as the name suggests, it's an Indian bank. So in 2011, I was into my initial phases of Goldengate. It was my, I think, 5th or 6th project only. So what happened? Their database size at that moment was 43 terabytes at that moment in 2011. Now it must have grown to, I think, 80 or maybe more than that. So at that moment, what they were facing, they used to had lot of reporting jobs running on the main database, and they used to have a lot of nightly jobs. During that time, what used to happen, anyone from India can relate to this, and at that time there was a lot of customer dissatisfaction. The reason being, OLTP transaction and reporting jobs were running on same database. What happens is, reporting jobs in banking or telecom sector, it consumes a lot of database time. So what happened, I suggest, or I should not say as a team, we suggested them that they'll be having Oracle. They had a separate site. So their primary server was in Mumbai and secondary was in Hyderabad, India. So what we suggested, they use the secondary server in Hyderabad to use Oracle Goldengate replication. Their data guard used to lag behind 3 days. I have seen that. They used to have streams. Streams also used to lag behind a lot. So what we suggested them to use Oracle Goldengate to replicate data to the secondary server. And once we replicated the data to secondary server, Goldengate was quick because we designed in such a way that it was pretty quick. The maximum nightly job lag when there were around 100 or 500 GB of archives used to generate, the maximum lag I saw was maximum 30 minutes to 60 minutes. So what they did, once the data was getting replicated on the Hyderabad server, they switched all their reporting jobs onto the secondary server because the lag was around 8 to 10 seconds and reporting jobs can take that. So they switched all their reporting jobs to the Hyderabad server, and primary OLTP transactions were happening on source. As a result, there were so you can use your so there was a lot of performance improvement, and you can use your target server for reporting, live reporting basically. And Goldengate, as I mentioned, it can be used for business intelligence. So Goldengate along with ODI or Informatica, in fact, it can be used for business intelligence. So in Goldengate, you can add some extra product. So you can use Goldengate on the intermediate server, and Informatica or ODI can process the data which is getting replicated to intermediate server using Oracle Goldengate. So we'll be discussing about this during data filtration and transformation part as well. So Goldengate has a lot of solutions, current solutions available in the market. Why it is being widely used, how it is used, there are a lot of solutions available. So Goldengate allows capture and delivery from multiple databases and to multiple database, Oracle, IBM, DB2. So this is the list. So in this list, you can add Informix database as well as NoSQL databases as well. It supports multiple platforms like Windows, Linux, Sun Solaris, HP, UX, IBM, different variants like IIX, ZOS, to name a few. So Goldengate capability is huge and it is being widely used. So this is about introduction to Oracle Goldengate. Next, we'll move to architecture of Oracle Goldengate. Okay, so how Oracle Goldengate works? Oracle Goldengate architecture. So let us talk about architecture. So architecture of Oracle Goldengate is very important. Architecture of Oracle Goldengate is basically whenever you are setting up Goldengate, configuring Goldengate, troubleshooting Goldengate, if you know the architecture of Goldengate, you can do anything in Goldengate. That's what I always say. So Goldengate architecture is really very important to learn. So how Goldengate works is you have source database and target database. So source database can be Oracle or non-Oracle, target database could be Oracle or any non-Oracle supported database. Each database has its own transaction logs. So Goldengate architecture, when I'll discuss, it is really very easy, but how it works, see, you have to understand how process data flow, and that we'll be doing as and when the session comes. Whenever we'll be troubleshooting, I'll be focusing on this architecture a lot. So this may seem easy, but it's not that easy. Again, I say, just like Oracle database architecture, if you know database architecture, you people say that, and I also say that you have learned 70% of Oracle database if you know the database architecture. Same with Goldengate. If you know the architecture, you can set up, manage, troubleshoot, configure Goldengate. So architecture is very important, and we'll be following this architecture very closely in all our sessions. Okay, so Goldengate architecture. So Goldengate replicates the data from source to target. So you have source database, which is Oracle or any non-Oracle database, any non-Oracle supported database. Similarly, you have target database, which is Oracle or any non-Oracle supported database. So each database has its own transaction logs. In case of Oracle, we call these transaction logs as redo logs, a backup of redo logs, which are known as archive logs. Okay, so whenever you do any transaction in Oracle Goldengate, whenever you do any transaction in database, those transaction comes into the transaction logs. So transaction logs contains committed as well as uncommitted data. Now what happens, you set up Oracle Goldengate capture process, which is also known as extract process. So you set up Oracle Goldengate capture process in the database, which captures the committed transaction. So which basically receives the changes from transaction logs of database in a sequential manner and captures only committed transactions. Now, once it captures those committed transactions, it writes them on the operating system file, which we call as trail files. So these trail files are like archive log files, I should say. These are binary format files which reside on your operating system. They consume space on your operating system. As soon as data becomes written into the local trail file, so basically trail file which resides on the local machine, on the source machine, are known as local trail. So capture process captures the data, writes them to local trail. As soon as data becomes available into local trail, Goldengate data pump process reads the data out of the local trail, sends it over TCP/IP network, and writes it to remote trail on the target database. So capture process reads the changes or receives the changes from the transaction logs of the database, captures those changes, and writes them to the local trail. As soon as the data becomes available into trail file on source machine are known as local trail because they are local to the source machine. So capture process captures and writes them to local trail. As soon as data becomes available into local trail, Goldengate data pump process reads the out of the local trail, sends it over TCP/IP network, and writes them to the remote trail file on the target machine. So these trail files resides on the target machine, and these trail files resides on the target machine, and these are known as remote trail. The reason why they are called as remote trail because they are remote to this machine. So capture process captures, write to local trail, pump process reads the data from local trail, writes it to remote trail. Once the data becomes available into remote trail, Goldengate delivery process, which is also known as replicate process, reads the changes from the remote trail and apply those changes to the target database. So basically, if I have to again repeat, capture process captures the data from source database, capture process captures the changes from source database, writes them to the local trail. As soon as data becomes available into local trail, Goldengate data pump process reads the data from local trail and sends the data over TCP/IP network and writes it to remote trail. Here there is one more process which is a background process involved. So It's known as collector process, which collects the data on target database and writes it to local trail. Once the data becomes available into remote trail, the replicate process reads the data out of your remote trail and apply it to target database. So there are three processes involved: capture, pump, and delivery. One background process is collector process. Each process has a
Question.
source to read from. Each process has a source to read from and a target to write to. So capture process source is transaction logs of the database and target is local trail. Pump process source is local trail and target is remote trail. Delivery process source is remote trail and target is target database. So always remember there are three processes involved in Oracle Goldengate: capture, pump, and delivery. Each process has a source to read from and a target to write to. Now, Goldengate capture process, I again repeat, it receives the changes from source transaction logs and captures only committed transaction and writes it to local trail. Local trail is being read by data pump process. It sends the data over TCP IP network and writes it to remote trail. Replicate process or delivery process reads the data out of a remote trail and apply it to target database. So remember here, it's only the committed data which is flowing through over here. If there is any uncommitted data in transaction log, Goldengate capture process is not going to capture. So capture process captures only committed transaction. As a result, you have to understand that Goldengate only writes committed transactions from source to target. Now, each process, whatever is listed over here, is independent of each other. And you will see as and when we do the practical. So you will find that so you see here capture process, pump process, and delivery process configured over here are independent of each other. That means that your capture process can continue to run even if your pump and delivery are down. The pump process can continue to run even if your capture and delivery are down. Your delivery process can continue to run even if your pump and capture are down. But remember, this is troubleshooting tip which I'm giving you right now. This will be very helpful when you are setting up Oracle Goldengate. That's fine. So remember here, even though each process is independent of each other over here, however, for data wise, pump process is dependent on capture process. So pump process is reading the data from local trail. And who is writing data to local trail? It's the extract process. So for data, pump process is dependent on capture process. Similarly, replicate process here is reading the changes from where? It is reading the changes from remote trail. Now, who is writing data to remote trail? It's the pump process. So basically, each process in Goldengate, like pump, is dependent on capture. Delivery or replicate process is dependent on pump, which in turn is dependent on capture. So if, remember, what I have seen what people do as an administrator, when someone says data is not getting replicated, what we do as a wrong practice is we start our troubleshooting from the replicate side. However, as I mentioned, can replicate apply the data what extract hasn't captured or returned to local trail? Definitely no. So you have to ensure capture process has captured it and return it to local trail. If capture process has captured it and return it to local trail, ensure pump has read and returned to remote trail, and then only replicate can apply. So if capture has captured, return to local trail, pump has read and returned to remote trail, then move your troubleshooting to your replicate side. So you have three processes involved, and remember, once again, this will again come to you as a handy point. Each process has a source to read from and a target to write to. Capture process source is source database transaction logs, target is local trail. Pump process source is local trail, target is remote trail. Delivery process source is remote trail and target is target database. Now, bidirectional, Now, bidirectional another capability of Goldengate is it supports bidirectional replication. Bidirectional means both the sites can be active. That means that application can be connected to site A as well as site B. Transaction can happen anywhere. So if the transaction is happening on site A, it should be replicated to site B. Similarly, if the transaction is happening on site B, it should be replicated to site A. So basically, I always say one thing: bidirectional is nothing but two-way unidirectional. So just like you have set up Goldengate from site A to site B, now consider you have to set up Goldengate from site B to site A. So bidirectional is nothing but two-way unidirectional with some considerations, which we'll be discussing definitely during our bidirectional topic. So when you have site A to site B, so when the replication was happening from site A to site B, you had capture, pump, and delivery. So capture process was configured on site A, pump process was configured on site A, corresponding replicate process was configured on site B. Now when you have to replicate the data from site B to site A, what happens is now your site B database has its own transaction logs. So you set up Goldengate capture process, which will read the data sequentially from transaction logs and captures only committed transactions. Once the transactions are captured, it writes them to the local trail. Once the data becomes available into local trail, data pump process reads the data out of your local trail, writes it to remote trail on site A. And then the replicate process on site A will apply the database to site A database. So you see each in this environment in bidirectional, you have capture, pump, and delivery along with local trail and remote trail, each present on both the sites. However, each process is independent of each other. Capture process of site A, pump process of site A has a corresponding replicate process or delivery process on site B. Similarly, capture process and pump process on site B have a corresponding replicate process on site B along with local trail on site B and remote trail on site A. So this is how process data flow. You have Goldengate capture process, which captures the committed transaction, writes them to the local trail. Once the data becomes available into local trail, pump process sends the data over TCP IP network and writes them to remote trail. And when the data becomes available into remote trail, Goldengate delivery process applied to target database. And then in bidirectional again is nothing but two-way unidirectional with some consideration. Now, at the starting of the session, I was talking about types of extract, types of replicate. So remember, again, I repeat, capture process is also known as extract. So during the session, as the session goes on, you'll see we'll be referring capture process as extract process and delivery process as a replicate process. Okay, so now at the starting of the session, we were discussing about type of extracts and type of replicates or type of extracts. So now what happened is, we have two type of extracts available: integrated extract and classic extract. So what happened is integrated extract. So when Goldengate was launched, there was only one Goldengate, one type of extract available, and that we call as classic extract. We call it as a classic extract. Now what happened from Oracle Goldengate 11.2.0.4, integrated extract support was introduced, and for minimum you need to have DB version 11.2.0.3. so to configure the integrated extract, the Goldengate version, minimum Goldengate version needs to be 11.2.04 and minimum database version needs to be 11.2.03, and it is available only for Oracle databases. It is available only for Oracle databases. Classic extract is available since beginning and still it is available. However, with multi-tenant databases, the support is not there from 12c onwards. So classic extract is there since beginning. So in fact, if you have non-Oracle database, you will be using this classic extract. So it is still available, in fact, even in 19c as well. However, with database 20c, Oracle is having only multi-tenant architecture. So definitely if you have Oracle database 20c, In that scenario, definitely you cannot use this classic architecture. The reason being, it is not supported with multi-tenant architecture. So what is the difference between integrated extract and classic extract? Now what happens is, what I was talking about here as an architecture, it is known as classic architecture. How it is known as classic architecture is, if you see this architecture, what happens is, capture process is establishing the connectivity with the database and reading the transactions of the database in sequential manner. So basically, it is reading the transaction logs of database is in sequential manner. So there will be system transactions as well. So say for example, you have 100 schemas available into the database. You want to capture the data. So one of the major capability of Goldengate is it can filter out the transactions as well. You can filter out the transactions. So say for example, there are 100 schemas in database. However, you want to capture the data of only 2 schema. Out of those 100 schemas, there are 100 tables. You want to capture only 2 tables out of those schemas. So what Goldengate does is, it connects to the database and it reads the transaction logs in sequential manner and captures only committed transaction. Now what happens is, Goldengate is a tool which is external to database. Now this is known as classic capture, in which case it connects to the database and reads the transaction logs in sequential manner. So that puts a bit of, so you remember in the initial discussion I mentioned, Goldengate is a tool which has impact on the database. Now because it does like that, we cannot say it is zero impact product, though the impact is very less. But yes, Goldengate being an external tool to the database, it has impact on the database. So what happened, and again performance wise also, it was a bit low. We'll discuss why. Now what happened, from 11 to 04 Goldengate onwards, Goldengate introduced the support for integrated extract. So what happens in integrated extract is, now in classic, extract was connecting directly to the transaction logs of the database, that is redo logs or archive logs. However, with integrated extract, what happens is, you have one more layer in between of transaction logs of database and extract. There is one more layer in between, which is known as log miner database. So what happens is, it is internal to database. Log miner, you don't have to do anything. You must have seen log miner is same what you have to do, like if you have to read the archive log. So log miner build happens as soon as automatically it happens. You don't have to do any extra step. So what happens is, whatever changes are getting returned to the redo log, same changes are available in the log miner, and then log miner passes on the changes, whatever changes are needed by the extract process, in form of LCRs. LCR stands for logical change records. LCR stands for logical change records. So integrated extract, what is happening now, prior in classic extract, what it used to do was, it used to establish the connectivity, and then it itself used to read the transaction logs on its own, and then capture the changes whatever is needed. However, now what extract process does is, it receives the changes from the log miner database in form of LCR. So there are internal processes which runs in the background, like a preparer, a builder. Then there are 4 processes which this integrated extract do. So those 4 processes, internal processes, basically does that task for you. So what happens is, prior to integrated extract, all that work was done by the external tool called as Goldengate extract process. Now all the transactions, whatever is needed by the Goldengate processes, that log miner passes on in form of LCRs, logical change records. So say for example, you did some changes in the database. So what happened? Those changes will be returned to the redo logs or archive logs, and copy of those changes will be returned to the log miner. And then say for example, there are 100 schemas in database. Log extract process just need data of 2 schemas. and those two committed. So log miner will pass on only the changes which are needed by the extract process in form of LCRs, and then extract process writes them to local trail, and data pump then writes it to remote trail on target database. So here now between classic and integrated extract, the difference is, so when you configure, you just have to set up integrated keyword. There is only one keyword difference, which is integrated. However, internally there is a difference. Internally, when you go, there is log miner build which happens, and it passes on the changes to the extract process in form of LCR. Now you may wonder, so the performance of integrated extract is much faster than the classic one. The performance of the integrated extract is much faster in comparison to the classic extract. And another thing is, prior to integrated extract, as I mentioned, Goldengate is a tool which is external to the database. Now it has some impact on the database. So when you set up classic architecture, as per my experience, I am telling you, it puts 1 to 5% of load on the database. However, when you use integrated extract, the load on the source database is still there, but it is almost 1/10 or 1/8. I should be specific. It is 1/8 in comparison to what classic extract has. Now you must be wondering, when you look at the architecture logically, there is one more layer in between of extract and redo logs, which is log miner in case of integrated one. However, here there is no layer in between. So basically, if you see logically the diagrams, or if you logically look at the architecture, you must be wondering that the performance of classic extract should be higher than integrated one, right? Does anyone has that question? Does anyone has that question? So if I look at the architecture of Oracle Goldengate, so if you see logically, so the integrated capture performance should be lesser than classic one logically. The reason being, there is one more layer in between, which is log miner. However, in classic, there is no layer. But how come performance of classic is higher than integrated one? Anyone would like to answer? I
Yeah,
hope you
hi.
got my question. I hope you got my question.
Hello.
Yeah, Rajneesh.
Yes, I just want to try my guess. I think because analyzing the data is just like analyzing the data in a like complete warehouse, and is like one thing. Either you just take some data and analyze external to some from apart from your warehouse. So that will be the faster, right? Because same redo log file database is also writing in a same redo, and we are analyzing which is committed, which is not committed. So I think it will be more burden to the database compared to like capture only committed, which is like with the help of log miner, and then analyze and then do our transaction.
So Rajneesh, you are very near, and I would appreciate you are correct. So anyone else would like to answer, or anyone else has any different opinion what Rajneesh mentioned?
Ashish, Mushumi here. So I think in the log miner, they filter some data, what is the needed for the local training. That's why the performance is good.
Okay, okay. Anyone else would like to answer? So Rajneesh, you were correct. Mosmi, you are also fine, but your answer is not exactly what I am looking for. But yeah, your understanding is fine.
Yeah,
Okay.
actually,
Yeah.
Ashish, okay, reading the transaction log from the archive or the online is have the burden on the database, but reading from the when you make log miner, you are making the change data a copy, okay, instead of the online redo log file is writing the log miner, and reading from log miner is much faster than reading from the online redo log or the archive log file. That's the basic difference, right?
Exactly. So the difference is, so basically why integrated is faster than classic, and in fact it is recommended to use Oracle, in fact, recommend to use integrated extract in case of your any environment if you are using, if integrated is supported. The reason I'll tell you now. So the answer, thanks for giving the answer, Rajneesh, Mosmi and Subhash. So the reason being, see here, the capture process is reading the transaction logs in sequential manner. Now what is happening, capture process is not internal to database. Capture process is a process which is external to the database. Now because it is external to the database, it has some performance impact definitely, and it takes time. However, here the same work what capture process is doing in classic, log miner is doing it. It is filtering out the transactions, whatever is needed by the extract process, and then passing on the changes directly to the extract process. So integrated extract is much faster than classic. So now if I have to give you the example of this, consider a scenario wherein you have, say for example, as I mentioned to you, you have 100 schemas. In 100 schemas, you have 1000 tables. Now your extract process, as I mentioned, and you will see data filtration, Goldengate can capture only 2 schemas, and in 2 schemas, total 2 tables it can capture. 2 tables which are DEPT11 and EMP11. Now your redo logs will contain data from sys, system, and all 100 schemas. So remaining 99 schemas, or sorry, 98 schemas, and then 2 schemas. Right now, consider there are right now 10,000 transactions from sys, 1 million transactions from system, then there are another 100,000 transactions from other schemas, and then there are transactions, 5 transactions from, then there are 5 transactions from these 2 schemas. So if you see here, if classic extract has to perform, even though the transaction reside here, classic extract reads the transaction in sequential manner. So what happens is, it will read first these 10,000 transaction and see the data related to two schemas is there or not. Then it will read this, then it will read this, and then it will read and it will capture those. So in this case, because classic extract is external to the database, the performance will be less. However, when it is done by internal database utility, which is the log miner is internal to the database and it happens automatically, you don't do anything. So in that scenario, the tool which is internal to the database, it also does the same thing. It will analyze these transactions, and then it will find that extract process needs these 5 transactions and will send these 5 transactions, whatever is needed by the extract process, it will send those 5 transactions to the extract process. So integrated extract is the new feature of Golden. I should not say new feature. It was introduced in 11.204, and it mainly, many places it is, means I should say most of the organizations have upgraded it. Now Mayank is asking one thing, why do people still configure classic? So remember, integrated extract is the feature which is only supported with Oracle to Oracle, which is only supported for Oracle databases. And another thing is, some people wants to go only with traditional. So like I'll tell you one of my client, okay, so why people use classic. So some people don't want change. They don't want to, basically they don't want, I should not say they don't want change, but they don't want to break existing, they want to break anything, whatever is running, whatever is there in current scenario. So one of my client, in fact, right around 2 months ago, I'm telling about, it's a big bank here, but they are just using Goldengate for replication, and they are replicating around 50 GB of data. Now they have Oracle database 18C, and they are using non-multi-tenant database architecture, and they are using Goldengate 12C. So I suggested them that they should upgrade their architecture to integrated one. I suggested them that the latest deployment, what I did, it should be done on integrator. But they said that because they have existing things on classic architecture, they want to go with classic. I tried to persuade them. In fact, Oracle also suggested them, but it's organization's call. So depending on if if it is supported, so in this scenario I did all the checks and integrated extract was supported. So as a result I suggested them, but still they didn't agree. So there can be multiple reasons why people are still using classic, not to break whatever is running, or maybe it is not supported in some of their environment, or another thing I'll tell you, integrated extract support is much extensively there. Whatever classic supports, integrated supports. Apart from that, it has a lot of extra benefits, like you don't have to do any extra setup for ASM or rack. So in ASM and rack you have to give like threads, or you have to create an ASM user. With integrated capture you don't have to do any extra configuration. So Oracle recommendation is still, if integrated extract is supported, go with integrated extract. Okay.
Ashish,
So let us now discuss about type of extracts and type of replicats. So there are different type of extracts and type of replicats available. So
Ashish,
integrated extract and classic. I'll take the questions. So there are two types of extracts available: integrated extract and classic extract, as I mentioned. So for configuring the classic extract, for configuring the basically the integrated extract, you will see we just put the keyword integrated one. Okay, and for classic I'll tell you how do we set up. So I'll tell you the command for setting up classic during the session. So during the session we are using multi-tenant architecture, and we'll be setting up integrated extract and integrated replicate. Now there are multiple types of replicats available. What are types of replicats available? In non-integrated replicate, non-integrated or classic replicate. So non-integrated or classic replicate is available. Integrated replicate, the support is available from GG 12.1 and database 12c, I guess. So integrated replicate support, so integrated extract support was introduced in 11.04 Goldengate and database 11.03. Integrated replicate support was introduced in 12.1 database, and I guess database also is 12c. However, I'll need to recheck which database this support came from, but I believe it came from database 12c only. Then you have coordinated replicate. Coordinated replicate was introduced in GG 12.2. Okay, and then you have parallel replicate introduced from GG 12.3. Parallel replicate is introduced, and there are two types of parallel replicate: parallel non-integrated replicate and parallel integrated replicate. So parallel non-integrated replicate, minimum DB version needs to be 12.1 and GG version is 12.3. For parallel integrated replicate, DB version needs to be 12.2 and GG version needs to be 12.3. So you have these types of replicates available. So yeah, integrated replicate support is available from 12.1 only. Database 12c. Okay, so these are the types of replicates. So during the session, we'll see how to configure integrated replicate, parallel replicate. With the introduction of parallel replicate now, coordinated, I should not say it is obsolete, but now coordinated replicate, in my opinion, I won't be using coordinated replicate anymore. I will definitely be going with parallel replicate. So parallel replicate introduction. So during the session, we'll be discussing about parallel replicate, integrated replicate, non-integrated replicate. We'll be discussing all about that. So the difference between integrated replicate and coordinated replicate is basically you can define user-defined partition of workload. So basically what happens in integrated replicate, it's an automatic partition of workload. So basically, say for example, there are 100 transactions happening. So integrated replicate can handle it on its own. You can define parallelism, and based on parallelism, multiple apply servers runs. Now in coordinated replicates, what happens is you define you divide a main replicate, say for example replicate 1, into 3 separate replicates, just for an example, and if you have 100 transactions to be replicated, so what happens is, if you configure coordinated replicate, so you'll define a range. So transaction number 1 to 33 will be managed by replicate 1. Transaction number 34 to 66 will be managed by replicate 2. And transaction number 67 to 100 will be managed by, so whatever updates, deletes, and inserts comes based on the key column, the different replicates will take care of it. So now the introduction of parallel replicate is multiple appliers and multiple mappers can run, and the performance of parallel replicate is 5 times faster than the traditional replicate. So we'll be discussing all about this type of extract, type of replicates during our training session. So there are two types of architecture available. I again repeat, classic architecture and microservices architecture. Classic architecture is a traditional architecture, which is command prompt based architecture, which is GGSCI. Microservices architecture is the latest architecture which has been launched, keeping Goldengate integration with cloud application, as well as it is GUI based architecture. So during the session, we'll talk about classic architecture. Types of extract: integrated extract, classic extract. Types of replicate: non-integrated replicate or classic replicate, integrated replicate, coordinated replicate, and parallel replicate. Now parallel replicate again is of two types: parallel non-integrated replicate. So this non-integrated replicate can be configured in parallel, and this can be configured in parallel. And this support has been introduced from database version 12, Goldengate version 12.3 onwards. Okay, so yeah, someone had a question, you can ask.
Ashish?
Yeah, Manoj.
So you told the difference between the classic extract and the integrated extract. So in the classic extract, it directly reads the transaction logs in a sequential order, right? No matter how many transaction it comes through. So it has to scan all the transactions and then pick the ones that we configured for the extract, right?
Exactly, yes.
But whereas in logminer, it's still all those, say for example, in the classic extract, it has to scan 10,000 transactions in the sequential order.
Mm-hmm.
Those 10,000 transactions were written to the logminer as well, correct?
The copy of the changes, whatever changes are there in redo logs, the copy of the changes gets returned to the redo logs.
Right. So in the logminer, when the logminer database, it also has all those transactions as well, right?
Yeah, that's what my understanding also says. Yeah.
Okay. So the only difference, the benefit out of this integrated extract is it just send the records in the form of SQL statements like the LCRs.
No, it's not SQL statement. It is LCRs. So Goldengate is itself a SQL apply. So Goldengate sends the data in form of LCRs, which is known as logical change records. So this is internal, and LCR stands for logical change records. So logminer basically whatever changes extract needs, it sends only those changes in form of LCRs.
Yeah, when you say LCR, is that like a binary format or is just the SQL statements?
No, so
The
it is
data?
internal. It is logical change record. So it is internally with which logminer sends to the extract, and then extract writes those changes to the local trail.
Okay.
So in the way it is written into local, so you can see the data only return in local trail or in the database, or if you want to mine the archive log, you can mine. So these are the places where you can see the data. Apart from anywhere else, you cannot see the data.
Okay.
Okay, so these are the type of extract replicate. So again, repeat the architecture of Goldengate before I move to next things. So Goldengate, each database has its own transaction logs where the transaction gets returned. Goldengate capture process reads the data or receives the changes in the sequential order, and it receives only committed transactions. Once the transactions are captured by the extract process, it writes them to the local trail. Once the data becomes available into local trail, data pump writes those changes over TCP/IP network and writes them to the remote trail. Once the data becomes available into remote trail, then delivery process or replicate process writes the data to the target database. Okay, so
Ashish,
these are the processes involved in Goldengate, and each process, I again repeat, has a source to read from and a target to write to.
Ashish,
Yeah, Tenny.
yeah, before you proceed, I was just trying to go back to the log miner. It's just a plus. The log
Yeah,
miner
sure.
also plays a very big role when it comes to troubleshooting missing transactions, because whatever transaction is being captured from the redo log is actually a copy of it is added to the log miner. So this plays a very big role when it comes to troubleshooting missing transactions in Goldengate.
Exactly, yes. Exactly, yes. So log miner really, so log miner itself, we should not say, in fact, in Goldengate at the database level as well. Like if you have to mine the archive log, you do it through log miner only. So yeah, log miner plays a big role in that scenario.
So Ashish, you mean to say, okay, maybe it's a basic question, I don't know. So the online redo logs and the log miner, so log miner will have only the committed transactions. Am I correct or
No, no,
not?
I
Like,
don't think so. No, log miner will have committed as well as uncommitted transactions.
okay,
So
in that case,
basically, log miner has copy of
copy of online redo logs.
basically all the all means insert, update, delete, DDL. So your redo log basically contains, so you to understand log miner, log miner is nothing but copy of redo logs. So redo logs contains committed as well as uncommitted transactions. So same thing with log miner.
So in the classic extract, you said it will be sequential. In integrated, so will it be going to be a sequential or what? How a parallel or something? How it will filter
So
the?
internally,
Yeah.
so this is just for your understanding. Okay, I'll tell you one thing. Just for your understanding, this is what integrated extract do. Now, what you have to understand is externally when you set up, you will be setting up Oracle Goldengate like that. Okay, so things will become more clearer as we do the practical. So in the next session, we'll be moving with download installation of Goldengate. Then we'll be setting up Oracle Goldengate. So what happens in Goldengate is Goldengate apply the changes in the commit sequence order. So we'll be discussing all that in the upcoming sessions. So these things will become more clearer. Just for our understanding for now, understand the architecture of Goldengate. It contains three processes: capture, pump, and delivery. So I'll again say this integrated extract is just for your understanding how integrated extract works. However, for your knowledge of when you set up Goldengate, it works like this. You will set up the capture process, which and define the local trail, then define the pump, define its source as local trail and target as remote trail, and then define the delivery process or replicate process whose source is remote trail and target is target database. So once we do the practical, this what we have discussed today, we'll be implementing it in the practical session. Okay, so one thing is I take more questions in next 5 to 10 minutes. So before that, I just want to show, because we are about to come to the end and people might have to leave. So related to the sessions, so you might have received few emails. If you haven't received, they must be underway. So you must have received the email related to enrollment. So you can check what courses you are enrolled with. Then you must have received email related to the activity guides. So do download the activity guides from this link. And then you must have received the email for lab setup for practice. So do download the lab setup kit from this location, which is given, which you have received in the email. So you have to download it. Now, one thing what I want to tell you is that right now my VM, what you have in the link, they have Oracle Database 12.1 and Oracle Goldengate software 12.2 available. However, I'll be upgrading those VMs to database version 12.2 and Goldengate version 19c. So by this weekend, hopefully it will be, the latest VMs will be available. If you've already downloaded, so you don't have to download them again. You might need you can upgrade your database from 12.1 to 12.2, either upgrade it or remove the old database 12.1 and download and create a new database 12.2, and you can download 19c and transfer it to VM. Okay, so I'll be refreshing the VM by this weekend, hopefully. If I'll update you with that and you'll get that. Now, related to the VM setup, another thing what I want to tell you is once you have set up the email, once you have set up the VM, also ensure one thing that you do ifconfig. Also, I always ensure that you may find some issues related to port in use. So why that comes is you should do, once your VM are set up, sorry, do ifconfig and get the IP address. Once you have the IP address, modify your /etc/host file. You can only modify it through root. So modify it. You should ensure that the IP address is correct, like gget2. So if it is, what is under whatever you see in ifconfig, your /etc/host should contain the same IP address. So if your gget1 IP address is, say for example 104 or 102, put it over here and save it here. Otherwise, if your ifconfig, say for example, says IP address as 107 and here you have 102, so what will happen? You'll get port in use when you are trying to install the database or when you're doing anything else. Okay, so yeah, so
we need to see ETH0 when you do ifconfig.
Sorry,
we need to capture the ETH0 IP address.
You can capture anything, ETH0 or ETH1 or any IP address. So this machine will work on both. If I put the IP address as 104 or 102, both.
Oh, okay.
Okay, so do set up the lab. If you haven't done that, do set up it. So in the next session, what we'll be doing with, we'll be starting with downloading Oracle Goldengate 19c from the OTN, and then we'll do the installation, and then we'll meet the prerequisite to set up Goldengate, and then we'll proceed with setting up our Oracle Goldengate replication. So in my environment, I have set up two machines, two virtual machines, Gate1 and Gate2. Remember, for running the virtual machines, pre-cooked virtual machines, which I'll be providing, you need to have minimum 8 GB of RAM and 100 GB of hard disk space, and virtualization should be enabled, which anyways is there in current laptops. Okay, so we'll be continuing with our sessions. So next session, as I mentioned, we'll be continuing with download and installation of Goldengate.
This conference will now be recorded.
Yeah, so regarding the certification matrices, right? So can we use the, so you mentioned two things, okay? One is 12.2, 12.3 Goldengate, and then I mean, just now I'm hearing like 19C. So I think 12.2 means 19C, right? Correct me.
Now 12.2 means 12.2, 12.3 Goldengate means 12.3, and 18C means 18C Goldengate, 19C means 19C Goldengate.
Okay, so they don't follow the regular, I mean, database nomenclature.
No,
okay. And however, that certification metric, like, you know, for 11.203, can we use any version of Goldengate, or is it like a top number only?
So always check the certification metrics. To do that, we'll be discussing about certification metrics in the next session. So make it a habit, guys. That's good point, Srinath. Make it a habit whenever you are going to install or set up Goldengate. Make it a habit before you proceed. Always check the certification metrics in your environment.
Yeah, I mean, that's okay, but I'm just asking your experience, like, you know, it's in some cases like it should be always higher number and all, right? So that's why
I'll
I'm
always
asking.
say one thing, go with the latest version, whatever is supported. So if 11.203 is supported by 11.204, 12.3 or 19C, I will always choose 19 if 11.203 is supported. Based on if OS is supported, so always means if I have to decide, I always choose the latest version, whatever is supported.
Okay. Okay.
Okay. Yeah, Manoj.
Ashish, on the parallel replicate, just one question. I don't want to get into much technical on that. So on the parallel replicate, you said we can configure multiple replicates on the parallel replicate?
No, I never mentioned that. So we'll be discussing about parallel replicate when we are discussing about parallel replicate. But I never mentioned in parallel replicate. Parallel replicate is one replicate which has multiple appliers and mappers internally.
Okay. Okay.
Ashish, I think he's talking about coordinated replica. I think that's what he's trying to mention. He's trying to talk about coordinated replica, where
Okay,
you
so
have
in coordinated replicate,
yeah,
coordinated replicate, you define multiple replicates in that. So
yeah, I think that's what
coordinated
he's
replicate is the one which is so basically a replicate is divided into multiple parts.
I mean, basically, for simple understanding, coordinated replicate is parallel replicate plus ranges or parallelism, which means if classic replicate plus parallel, so it's the same as classic replicate, but you just have more replicates in terms of range. That's coordinated replicate for me. If you understand that, you understand coordinated replicate.
Yeah, that's correct. That's correct. So I hope you got it, Manoj, right?
Yeah, it's actually the classic replicate is just the regular replicate, and the integrated, coordinated, and parallel replicate. It looks to me all the three work function is the same
No.
because it has a
So
parallel.
work function of all four is same. They just read the data from remote trail and apply it to target. Now, how they apply, it's just that's the thing which differs. So it can, the performance wise, everywhere it is incremented. Like integrated extract is much faster than classic one. Coordinated replicate is faster than classic one. Integrated and if you ask my personal experience, integrated extract is better than coordinated one. There is no documentation ever. So these are my words I'm telling you. And then parallel replicate is much faster than any of the traditional ones.
Yeah, I mean, it's because of the shortcomings of parallel of integrated replica that parallel replica came up. Because people use more and more transactions, more and more loads are being used, or people are replicating huge and larger tables. People keep complaining of lag, and lag. So that's why Oracle came up with something more faster, which is parallel. If you have an issue, I mean, if you have an SR from you and you want to resolve it and you say there's a lag, most of the times I will advise you if you're using 19C or 13C or 12.3, I'll tell you to why not try parallel replicas. It tends to be faster, and most of the times, 85% of the time, it solves customers' issues.
Exactly. Yes. And that is my personal experience as well.
So regardless of the setup or the requirement, even if we go for a parallel replicate, is it still a good practice to go with the parallel replicate because of its nature of the speed of writing it, or is it only required only
If you have something new, why not enjoy the functionalities of that? If you have the capability
my
of using
question?
19C,
Since we
why
have
not use it?
since we have the feature, and why not we use when we have a good feature instead of going
Exactly.
there?
So
That's the question.
if it is supported, if anything is supported, always try to make use of that feature. I
Yeah.
always say
Basically,
the
the
only time
resources should be very huge, right? If you're using the parallel, okay, that's important, right? The resources.
the only time you will not use parallel is if you're doing a heterogeneous environment, a heterogeneous replication. Remember, integrated parallel doesn't go for heterogeneous, but classic now goes in that way. I don't know if I'm correct there, Ashish.
sorry, I missed that part, and it wasn't clear.
I
Can
think
you
the only time you want to go for most of the times you want to go for classic if you want to go for classic when you're using when you're doing a heterogeneous replication, like from Oracle to something else or from something else to Oracle.
Oracle to
That's when
MySQL or SQL Server, exactly.
So Ashish, in your this Goldengate support for the other databases, I see somewhere ODBC for few databases. So only ODBC connectivity is supported for those databases?
Yeah, so most of the databases are supported with ODBC. So like in Goldengate, you'll see we connect through TNS, right?
Yeah.
So for SQL Server, you need to create ODBC connection, or DB2 if you have to create, so you need to create ODBC connection.
For DB2 also ODBC, but the performance, if when compared to native and ODBC, always the performance will be very low, right? So how is it for Goldengate with DB2 example?
I haven't faced that issue. Means performance wise, I don't think. Do you really think so? Once the connectivity is established, I don't.
Yeah, because in suppose in our suppose if you take an example, I work on ETL Informatica. So the connection we have for SQL, it will be ODBC, and whereas for DB2 it will be native. So the performance for the native is very good, and as well the performance with the other database with the ODBC is always the performance will be down. Not native drivers.
I'm not in the condition to comment on that because of it may be dependent on environment or something else. But personally asking, no, I haven't seen that issue. But yes, there are certain factors which may be causing that. It may not be only ODBC connection which is slow, but there may be some other factors as well.
Yeah,
so,
but only ODBC is supported for DB2, right?
Exactly, ODBC is supported for DB2.
So even from 12C and 19C also it's ODBC only.
Yeah,
no, 19, you said microservices is not supported at all, right?
19C Goldengate 19C is there for DB2. We'll have to check binaries. So whatever version is, you have to connect through ODBC.
Yeah. But microservices only
Microservices is only for Oracle to Oracle.
Okay, thank you.
Okay.
Ashish?
Yeah.
Yeah, this is maybe out of the box question. The source and target, right? The source server and the target server. When you do through the ODI setup, the business intelligence, they connect to the source Goldengate server using some ports, the JMI and RMI ports. I hope you know what I'm talking about. So do we have to open the firewalls for those particular ports when the ODI tool interacts with the source Goldengate server?
So it depends, right? So if you are making connectivity to the database, then definitely you need to open the firewalls to the database, because ODI basically establishes the connectivity with database, right? So you need to have the firewall open for the source, and to the database definitely open the firewall.
So is it just the RMI ports that we need to open, or which ports we are talking about when to establish?
So you should be able to. So basically, what you need to do is you should be able to telnet from your Informatica server to the database server port on which database is running on. So you need to definitely open the port, database server port from the Informatica server.
And Ashish, one more request. Actually, I mean, I'm new to this container and pluggable databases. So do you recommend any video which I can understand with the normal database terminology and this container and pluggable?
So there must be some documents. So I think yes, if you ask on the group or WhatsApp group, definitely you'll get something for that.
Sure. Or I mean, if you take an example next week when we start it, if you can explain in the normal database also, it will be fine.
Yeah, I do that. I do that.
Yeah, thank you.
Okay. Okay.
Yeah.
Ashish, I have a question.